So now the pH flow chart that you have, each corner here will be one of the species we'll need to convert to from one of the others. So I will point to the one that we have and where we're going, but ultimately we're going to be using these 6 equations. So those are the equations you need to make sure you're able to use. Okay, the first one. You're asked to calculate the pH given the hydrogen ion concentration. So the hydrogen ion concentration, we're calculating pH. So we're given the hydrogen ion concentration and we want the pH, and so the arrow here, the equation that's listed, is our very first equation, equation number 1. So that would be a negative logarithm of the hydrogen ion concentration, 2.2 times 10 to the negative 5. Now when you do this, make sure you show your work. Now on your homework, you may have gotten to it, the very last item is a table to fill out that's just like in the notes, and it specifically says you do not need to show work. But otherwise, you would need to show work. And so what do I mean by that? Just like what I have here. So this is the data I'm given. This is the equation I'm using. Okay, now to type this into your calculator, be 2.2 EE and then 5, and then change the sign on it, change the sign key next to the equal button. And you get 4.66. Remember, 2 significant figures, so 2 decimal places. Here to here. Now the next one, you want pH from the hydroxide ion concentration. So notice there's 2 steps that you would have to take, and there's 2 different paths that you can take. So let me do this path first. I'm going to convert the hydroxide to POH, and then convert it to pH. So there's 2 equations, or two steps for this. So the POH is going to be equal to the negative logarithm of the hydroxide ion concentration, which is the same number as we had before for hydrogen. So we'll get the same 4.66. But in this case, it's POH, not pH. Now, when you type this into your calculator, as I pointed out in the notes, what I advise you to do is to ignore the negative sign here. So when you type in, so don't type in negative and then logarithm. Just ignore it, and then ignore the negative sign that you get on the calculator. So it just makes things easier. If you're fussy about such things, then go ahead, type it in. But do not, and students often seem to confuse that negative sign with anti-log, and that's something completely different. So be careful about that. Okay, now so I converted the hydroxide ion to POH. Now I need to convert it to pH, and for that I'll use equation number 6, which is the easiest of them all. And it says if we add pH and POH, we'll always get 14. So if we subtract 1 from 14, we'll get the other. So pH is going to be equal to 14 minus 4.66. And that gives us 9.34. Now I'm going to write this up here. I'll refer back to it in a minute. So I went here to here to here. Now let's go the other way. Go from hydroxide ion to hydrogen ion to pH. And we should get the same answer. So the hydrogen ion concentration, we can calculate using equation number 5. Equation number 5 tells us the product of the hydrogen ion concentration and the hydrogen ion concentration will always give us 10 to the negative 14. So if we divide one into 10 to the negative 14, we'll get the other. Now when you type this into your calculator, it'd be 1 EE 14 and then change the sign, make it a negative number. Then divided by 2.2 EE 5, change the sign, make it negative, and then equals, and you should get 4.5 times 10 to the negative 10. And that would have units of molarity. So that conversion, now converting hydrogen ions to pH, well, we've done that before. It's the negative logarithm. And like magic, we get 9.34. The same answer we got going the other path. However, let me point out to you, when you did this calculation, if you didn't round this number, maybe you rounded the number correctly, but then you just kept that number on your calculator and took the logarithm of it, I believe you get 9.35, which is absolutely fine. And I tried to make a big deal of this in the notes. Don't worry about those trivial little differences in your answers. That's just a rounding issue, or depending upon what path you took. They are the same answer. Second for me. Okay. Next is the easiest one of all. You want to know what the pH is, and they give you the pOH, so that's just this step here. And that, all we need to do is use equation 6 and subtract the pOH from 14. Okay, next we want to calculate the hydrogen ion concentration. The first one, we're given the pH. And so for this one, we want to use equation number 2, where the hydrogen ion concentration is equal to the antilog 10 raised to the power of negative pH. Make sure it's negative or your number's going to be way off. So 10, the negative 9.32. So to type this into your calculator, just type in 9.32 and then change the sign, make it a negative, and then the second function logarithm, which is the anti-log key. And for that, you'll get 4.8 times 10 to the negative 10. That was going from pH to the hydroxide ion concentration. Okay, the next, I would suggest, so you can take two different paths. We want hydrogen ion concentration, we're given pOH. So we're here, we want to go here, so we could go either path, but I think anytime I'm given pOH, and it's a two-step problem, or pH and it's a two-step problem, I always go through this path, because it's the easiest of all the equations, just a simple subtraction problem. So pH is going to be equal to 14 minus 12.5. And that gives us 1.5. So we're now here, and then we want to go here. So that, just like the problem we just did, you need to take the antilog of negative pH. And that gives us 3.2 times 10 to the negative 2. But for those of you paying close attention, you might notice there's a little discrepancy here with sig figs. If this has only one decimal place, well then this should only have two significant figures. I'm sorry, if this has only one decimal place, then this should have only one significant figure, but let's not worry about that. Okay, and then the last one, you're given the hydrogen ion concentration, or the hydroxide ion, and you want the hydrogen, so that's just this step here. So that's equation number 5. So we'll divide into 10 to the negative 14, the hydroxide ion concentration of 4.3 times 10 to the negative 8. Okay, now for those of you playing at home, why don't you go ahead and type that in? There's something I wanted to point out to you here. So 1 EE 14 negative divided by 4.3 EE 8 negative. Now if you just did that, likely, unless you have your calculator in scientific notation, it's going to take advantage, your calculator will display all zeros possible. So you likely have a whole bunch of zeros there on your display. But remember, on our calculators anyways, you can easily convert that to scientific notation by hitting the second function 5. That puts it into scientific notation. So please don't stop and count. If you ever find yourself counting zeros, whack yourself on the back of the head and say, oh, no, I can hit the second function 5, and it puts it immediately into scientific notation, and you would get 2.3 times 10 to the negative 7. And remember, you can go second function 4 to go back to standard notation. All right, any questions on this?